Hello everyone. In this video we're going to be working on rational inequalities with sign analysis, and we're just going to be solving each of these, seeing whether they're greater than 0, less than 0, less than or equal to, and so on and so forth. So let's start with this very first one, and since we're wanting to see where it's greater than 0 or less than 0, we are working with the x values there, so we want to see if there's any values where it's going to change. So that's going to be vertical asymptotes, holes, or x-intercepts. Those are going to be values where things might change. The whole isn't really going to change from positive to negative, but it's just something to take into consideration. So the first thing that we need to do here is we need to factor the numerator and the denominator. So let's start out. The numerator is already factored, so I'm just going to write it as x plus 4, but I'm going to put parentheses around it just so it looks more like a factor. And then we're going to factor this denominator here. We have 1 times negative 32. It's going to give us negative 32. And we want two factors of negative 32 that add to give us positive 4. So factors of negative 32 are 2 and 16. We also have 4 and 8. So 4 and 8 are going to get us to that positive 4. Okay, we're going to be using positive 8 and negative 4. That will get us there. And since there was a 1 in front of the x squared, we can just use our shortcut and just jump straight to the factors. X plus 8. X minus 4. Okay, and we still want this to be greater than 0. Okay, so now we just want to look at the important points here, and we want to really analyze the x-intercepts and the vertical asymptotes. The vertical asymptotes are pretty easy to see. It's just the factors that are left over in the bottom, and we want to see what makes those zeros. So here it would be negative 8, and this one would be positive 4. So that's x equals negative 8, and x equals positive 4. We also want to look at the x-intercepts, and that's just going to be where the numerator is equal to 0. So since the numerator is x plus 4, what's going to make that 0 is negative 4. So our x-intercept is going to be negative 4. So we're going to make a number line, and we're going to do some sign analysis with each of these points here. Okay, so I want to put negative 8 on this. I want to put negative 4, and I also want to put positive 4. Okay, and I'm going to be testing points in here, a point in here, a point in here, and a point on the outside there. So we're going to be plugging in multiple points, and we just want to see, is this going to give us a positive, is it going to give us a negative? And we're trying to see where this is greater than 0, so we want to see where that is positive. So I'm going to pick a point over here. Let's just say x equals negative 9. I also want to pick a point in here, so let's just say x equals negative 6. I want to pick a point in here as well. 0 is between there, so I'll just put that. And then I want to pick a point on the outside here. So let's just say positive 5. Doesn't really matter what points you pick, but we are going to be plugging this in to this equation right here. This whole thing. So we're going to be plugging those points in, and we'll be plugging them in right in here. Okay, so I'm just going to go to Desmos, and I'm actually going to type in this equation here, and I'm going to look at the table just because it's really easy, spits out the numbers for you, and it turns out really, really nice. So let's go to Desmos, and I'm going to type in my equation. I'm not typing in the inequality, because that will not give me what I want here. Okay, so here is my rational function, and I'm just going to click the edit list, and then I'm going to click table here. And now I can just plug in my points. So the first one I want to look at is negative 9. There's that one. Then negative 6. Then 0. And then positive 5. Yes, these numbers are crazy, but we're going to write them down anyway. So negative 0.3846, 0.1, negative 0.125, and then 0.6923. Okay, and the only thing that we really care about is this positive or negative? So at the negative 9, I can see that this was negative. then it went positive, then it went negative, and then it went back to positive. So that's what I'm going to put up here on my sign analysis. So over here, mine was negative. Between these two, it was positive, then it went negative, and then it went back to positive. Okay, and I really want to see, where is this function greater than 0? So I want to see where this is positive. Okay, so I'm just going to shade the parts that are positive. That is between these 2 points here, and then for any value that is greater than 4. I also want to look and see, is this greater than or equal to, or is it just greater than? And here I don't see the little equal to sign, so I'm going to draw some open points here. Okay, now that we have done this, we can go ahead and write out our solution. So it's any point that is between -8 and -4, or anything that is greater than 4. So we can write this one of two ways. We can say x is between -8 and -4. And then we can say, or x is greater than 4. So this is one way that we can write our solution. And then the other acceptable way of writing the solution is actually in, interval notation. Yes. So we can say it's going to be between -8 and -4. And then we can say, and it's going to be from 4 to positive infinity. So any number that's greater than 4. So both of these are acceptable answers. They're just written in different forms here. Okay, so let's try our second example. We're going to do the exact same thing. So we're going to first factor. So let's factor, the top is already factored for us. So let's just put parentheses around it so it looks pretty. And we want to factor this denominator here. So what 2 factors of 6 add to give us -7? And we can see the only factors of 6 that we have are 2 and 3, and then 1 and 6. So we're going to be using -1 and -6. And we can just jump straight to our factored form since we had the 1 in the front. So x minus 1, x minus 6. And this was less than 0. Okay, now that we're here, we just want to look at the important points. So let's start with the vertical asymptotes. And those are just the factors that are in the denominator, what makes them 0. So here I can see 1 minus 1 would be 0, and 6 minus 6 would be 0. Okay, and we also want to look at the X-Intercept. The X-Intercept is where the numerator is equal to 0. So that's just really the same thing. What makes this thing 0? So that would just be +4. Okay, so we're going to be looking at these points here. So I'm going to make my line, and I want to look at 1, 4, and 6. And I'm just going to be testing points, seeing where things are going there. So I want to try 1 on this side. So let's just try 0. Want to try 1 between here. So let's just try 2. 1 between there. So let's just try 5. And then 1 on the end. So let's just try 30. It doesn't really matter, just as long as it's greater on this side. So let's see what these will spit out for us. And again, we're taking these and we are plugging them into this x right here. Okay, and I'm only going to type in this left-hand side, and I'm just seeing if these things are greater than 0. So let's go to Desmos. I'm just going to use the table again, since that's nice and easy. And I'm just going to delete what I had up here and just replace it. Okay, x minus 4 divided by x squared minus 7x plus 6. Okay, and I'm going to plug in my points. First one, plus 6. Okay. My first one that I want to try is 0. Then I was looking at 2. I was looking at 5. And I was looking at 30. Okay, so let's just write out these points. I know they're not the prettiest, but that's okay. The first one is 6 repeating, or 0.6 repeating, negative 0.6 repeating, sorry. Second one is 0.5. Third one is negative 0.25. And the fourth one, 30, is 0.037. Okay, so coming back to our work here, all we really care about is this positive or negative. So we can see it first starts negative, then positive, then negative, then positive. So I'm just going to go through and I'm going to mark this in my graph. So here it was negative, then it went positive, then negative, and then positive. And you should always see this alternating pattern unless we're talking about wholes, and then it might not alternate at the whole, but every other point should alternate. So looking back at the beginning problem, we wanted where this was less than 0, so that was negative. So I'm going to shade the negative parts here. Okay, and since this was not equal to, then I am going to draw my open points here. Okay, and now we can go ahead and write out our answer. And again, there's two different ways. The first way is writing it in this form, so with inequalities. And here we can say it is just less than 1. So x is less than 1, or, and then x is between 4 and 6. So 4, 6, like this. Okay, and then the second way of writing this out is with interval notation. So let's do our interval notation. This is anything in negative infinity all the way up until positive 1. So from negative infinity to positive 1. And then we also have the interval between 4 and 6. Okay, that is all that I have for this video. I'm going to do 2 more examples down at the bottom, so stay tuned. Goodbye.